Container of volume 50 cc contains air. Mean molecular mass is given and is open to an atmosphere where the pressure is 100 kilopascals. The container is kept in a bath containing melting ice. Find the mass of the air in the container when the thermal equilibrium is reached. Right. So basically volume is given as 50 cc. So I can convert it into meter cube, which is 50 into 10 raised to the power of minus 6 meter cube. Right. Volume is given to us. Now the pressure P is 100 pascals, 100 kilopascals. So that would be equal to 10 raised to the power 5 pascals. Right. Now the container is kept in a bath containing melting ice. Find the mass of the air. So mass we have to calculate. Now molecular mass is given as 28.8, and now temperature we also require, because if we have to calculate mass, then we require the equation PV equal to nRT. So for that we require the temperature. Now it is saying that in the A part, if I talk about the A part, this is basically the A part. Find the mass of the air in the container when the thermal equilibrium is reached. Thermal is equilibrium reached with the melting ice 0 degrees Celsius. That means temperature is 0 degrees Celsius or 273 Kelvin, right? So if I apply PV equal to nRT, so I can say that 10 raised to the power of 5 into 50 into 10 raised to the power of minus 6. This will be equal to number of moles. N is what? M divided by molecular mass, which is 28.8, into R is 8.3, into what is the temperature? 273, right? So basically, if you solve this equation, you'll get the value of M as 0.0635 grams. So this is fairly simple, right? Let us move on to the next part. The container is now placed in another bath containing boiling water. Find the mass of the air in the container. Now very similar question, similar to the part A, only the temperature has changed to 0 to 100 degrees Celsius. So this would be equal to 373 Kelvin. Now we will apply the same equation, PV equal to nRT. This equation will be applied. We'll put in the values, the same values. 10 raised to the power 5 is into 15 to 10 raised to the power minus 6, which is the volume. M divided by 28.8 into 8.3 R into 373. So from here we will calculate the value of the mass, which you will calculate 0.0465 grams, right? So this is the answer, first answer, second answer. And if I calculate this third part, the container is now closed. Container is closed and placed in the melting ice bath. Find the pressure of the air when the thermal equilibrium is reached. Now, since the container is closed, the pressure can change, right? So similarly, if we apply PV equal to nRT, right? So pressure, we have to calculate what will be the volume, 15 to 10 raised to the power minus 6, because container's volume will remain constant. Now what will be the number of moles? Now C part was done after B part. So basically we will take number of moles as what we have calculated in the B part, 0.0465 divided by of 28.8, right, into 8.3 into what will be the temperature. Now it is in melting bath, that means 273, right? So from here, if you calculate the value of P, you will get it as 73 kilopascals, right? You have to solve this and you will get this value, right? So this was another very straightforward question. We just have to use the equation PV equal to nRT and you will get all the answer, right?